and RhinoCam 2018 runs in Rhino 5. We also have RhinoCam 2018 for Rhino 6 as well. So the configuration I'm running here is the premium, but I know you have the standard configuration, and we'll cover the items in the standard configuration that you have questions for.
Great, thank you.
Okay. So I'm going to go ahead and load this part in, the one that you had emailed us. Okay.
Yeah, it's exactly the one I have right here.
Okay. So if I go to the 4-view layout, it shows that the part is oriented in a different plane. So if you want to machine this part, you would need to rotate it or reorient it. If you look at the Z-axis, X and the Y. So if you take a look at it from the 4 views. So are we looking to machine the top, the face with the holes, and then flip the part over and machine the other areas? Or
I think that would be, I was just going to say, I think that's how I was talking to the person who actually designed this piece. This is going on we build carbon yachts, and this is going on a plant for inside mold. And I was talking to the designer about this, and that's what we were basically saying would happen.
Okay, all right, perfect. So there's several different ways how you can orient the part. You can use the tools, the transformation tools in Rhino if you'd like to, or you could even use the tools that are in RhinoCam. So you can go up to the setup in here, and you'll find orient part. So this is available to you in all the configurations, and then you pick a surface, and you can pick that face right there, and you will notice that it'll orient it to that face, and you pick OK, it'll do a transformation for us. So you would need to explode this into surfaces so you can easily orient it. So I can go ahead and click on orient part, and I can say align to, you can say geometry to a surface. You can pick that. You can now see that the Z-axis is normal to that surface.
Okay.
So once you establish that, you can select OK, and now if you see that the part is automatically rotated for you.
Okay.
So that's one of the ways to do it, or you can use the Rhino's transformation tools to rotate it.
Okay.
All right. So I exploded the polysurface into surfaces, so I could select this face in here for basically being able to set the Z-axis to be normal to the face. So it looks at the normal direction, and then you're able to orient it. The next step is you want to go through the process of establishing the workflow for machining this part. So you go into the machining browser, you have this program tab, you select the machine definition, and by default it's set to 3-axis in standard configuration. The additional levels have, like Expert and Pro, have 4 and 5-axis if necessary.
Yeah, I saw that.
Okay, the next thing we want to do is select a post processor for it, and this would be the type of CNC machine tool or equipment that you have, and the post processor that it's currently using, or the control that it's working with. So the post processor is listed by the name of the machine tool or by the controller name. Do you happen to know what tool you're working with?
Yeah, so I work with a RhinoCam, a Multicam 5000.
Okay.
And that is not, the actual name of it's not on there, but I'm guessing if I contacted Multicam, they would tell me which processor would be the correct one.
I would recommend using the Multicam Inch. So this will work with pretty much most of the Multicam machines.
Cool, that's the one I was actually guessing that would work.
Yeah, and then we have a built-in post generator here, and we can make edits and modifications of the post as necessary, so we can tweak the post if needed.
Okay.
And we can help you with that. And Multicam machines, I would like to have the extension as .cnc, so you can click on extension as add new and enter in .cnc, since CNC is not by default listed in the posted file extension. So once you add it, it'll remain in there.
Okay, I see. So .cnc.
Okay, the next step is basically you already oriented the part, so we want to go ahead and define the stock, which is the workpiece. So in the standard, you can define a stock as a box or as a cylinder. And if you pick cylinder stock, you can actually, if you want to start with the round blank, you can do that. And then you can select to pick the axis to be about the Z-axis. And then you can select copy model bounding cylinder. So it'll try to fit a cylinder around the blank. And you can specify the radius and you can also specify the thickness, the height of the cylinder. So, or if you want to do a rectangular blank, we can start with a rectangular blank as well. So whatever your preferences are.
Let's do rectangular. It looks like here the circle, the cylinder was not covering the whole part though.
Yeah, so because the center, we need to make this slightly larger. It's kind of, the part is not fully round. It's has these
Yeah.
extensions, so we would have to modify that. So we can go with a box stocking here and specify a length, width, and the height you typically want to start with. Now, do you like working in inches or would you like working in millimeters?
Let's stay with millimeters.
Okay, all right. So you can set the length of the stock you would like to start with, width, and the height. So would you have any specific recommendations?
Let's see. What's your height? 157. Let's do a height of 175, and length and width don't really matter to me so much.
Okay, so maybe we'll add some additional room, so you need to be able to hold the part when you machine it, flip it over. So maybe we can add maybe we can maybe
600 or something.
we could do 600 and 600.
Yeah, that's great.
And then 175. So your stock is now defined, and in the next step you want to align the stock to the part. So pick align, and you can have it centered in X and Y. And for the Z, you can have it set to top, center, or bottom. So if you'd like to remove material both on the top and the bottom, then you can have it centered, so there's material that needs to be removed from both the sides. Or if you just wanted to have it flush to the top, you can pick top, so the Z0 is flush to the top of the part.
Sure, let's just do the top. That makes say it's flat.
Okay. All right, so I'm going to accept that. And then the next step, you want to set the XYZ 0 or the origin. So when you take this workpiece and place it on your CNC table, you'd want to zero out to one of the corners or maybe the center of the block, depending on where you'd like to put it in there. So you could do that by going to align, set world coordinates. You pick set to stock, and then I can pick highest Z southwest. So the Z0 would be set to the top face and then the southwest corner, and then we'll pick OK to accept it.
Usually because I've done some CNC with a different program, and I've set the Z to the bottom of the stock. We
could do that. It's just a preference on what you'd like to do. So we can do set to, we could do lowest Z, southwest. So that's
what difference does that make when I'm cutting it basically means that it's going in the negative direction.
Well, on most machine tools, if you put the Z0 to the bottom of your stock or the bottom of the workpiece, this would be a positive Z coordinate, so you wouldn't have any negative Z coordinate values. Now, in the case of a multi-cam router, it's slightly reversed. So from the origin, as the cutter moves up, it's a negative move, and as the cutter moves down, it's a positive move. We do that scaling of the Z coordinates in the post-processor.
Yeah.
So right now you'll have a negative Z value when you post-process the code out, so you wouldn't probably be seeing any positive values for Z.
Okay.
Okay. Now we wanted to start by programming this, so maybe you want to do a drill operation first to drill those two holes, right?
Correct.
So you can determine the size of the holes. You can do analyze a diameter. You could establish the hole. It's about 10 millimeters in diameter. So if you have a tool that's smaller than the diameter of the hole, you could use a 2D hole profiling or a hole pocket operation. Or if you have a drill bit that fits the size of the hole, you
Sure.
can
We have one that's would be, let's see, 3/8 of an inch, which is just about 10 millimeters.
Okay, so we'll do a drill tool. We'll select the features. I can pick a feature by selecting a face. I can just pick that face. It'll pick the two holes from the face.
Oh, cool. Very nice.
And I can define a drill tool in here. And I can go into the tool tab. I can even use an end mill for drilling. Or if you want to use a drill tool, you can specify it. And you said it was a 3/8 end mill?
Yeah, exactly.
9.525?
Yes, exactly.
Okay, so we can put it in there. We can say drill 3/8 or... And then I'm going to specify the same here. And the tip angle for the drill tool, typically drills are like 118 or 120. You can put
Right.
the information in here. You establish your tool number, and then you can establish your feeds and speeds as well. You can specify your spindle speed, your cut feed rate.
Yeah.
For
So
drilling, all that matters is the cut feed rate and the spindle RPM.
right. The load from file too. I noticed that like there's a file that actually contains some feeds and speed rates.
Yes, we actually have a table that
Mm-hmm.
helps you establish feeds and speeds based on the material you're going to be cutting, like based on the stock material, the tool material, and it also has, the surface speed, which is the property of the material. The feed per tooth is a property of the tool, and based off that, it'll give you a recommendation. So you can also set what your maximum RPM is for your machine tool. So this could
Mm-hmm.
be, your machine can go up to like say 24,000 RPM or 30,000
Yeah.
RPM. And a maximum feed that your machine can handle, I can put in, for example, it could be 1,000 millimeters per minute. So based on the tool diameter, which is 9.525, and it computes based on the feed per tooth, the surface speed, it computes the spindle RPM and the cut feed rate. If I change the spindle RPM, let's say to 8,000, it's going to
Mm-hmm.
recompute it. Since the maximum is set to 1,000, it doesn't go past that. So you can always set the maximum to be higher value, and also you can also lower the feed per tooth in here. So if I make this smaller, you'll see that it'll use a different value in here. So you can
Yeah.
specify, you know,
Okay. I
just
see. That's
notice that
cool.
right there. So you can change it, you can adjust it.
I like that.
Okay. So for now, I'm going to go ahead and accept this. I'll leave it as 500 and accept that. So that's the cutting feed rate. Save this up
Mm-hmm.
as a new tool. It says there's already a tool number found in the library, so I'm going to repeat it. I don't want to repeat the tool number, so click yes, and it'll assign a new number that's available in here. So we have the drill tool in here. You got the feeds
Mm-hmm.
and speeds being loaded from the tool. The clearance definition or clearance plane is set to automatic, so it'll automatically clear the maximum height of the stock of the part. And now here you can specify how deep you want to cut. So I can pick 2 points. I could say I want to start right over here, and then specify how deep I want to cut. Is I can go pick a quad point in here.
Right. And that knows just the Z direction, even though you did X and Y and Z. And knew only the Z direction that you just picked?
Yeah, I just picked the Z. I picked 2 points for establishing the Z direction. So now you can go to simulate and run a verification for it.
Okay. I can get something off.
Is that live speed?
No, it is not. It's basically a speed for the simulation. That's independent of the speed what you're going to be seeing.
Does it do live speed at all?
We don't do it at the actual cutting, feed rate or the machine. So we don't simulate the speed at which the machine cuts it. We have a machine tool simulation in one of the higher configurations, but again, the feeds and speeds that you put in is just getting output in the posted code. It's not used for the purpose of simulation.
Okay.
All right. So the next step is you want to go ahead and cut the outside in here, right?
Right.
And typically you would want to do a roughing operation and then go into a finishing process. So
Absolutely.
you would want to start with a roughing using like a 3-axis. So with the standard configuration you have horizontal roughing, parallel finishing, horizontal finishing, radial, and spiral. So you would typically want to start with the roughing process. So this would be a horizontal roughing.
Mm-hmm.
And you'd want to specify a tool for it. So I could pick a 1/2 inch or 3/4 end mill, whatever size end mill that you want to use for roughing process in here.
12.7 is perfect.
Okay, so we'll also have some feeds and speeds set, as you can see right there. And then you can go to your clearance. You can see that the feeds and speeds are being loaded from the tool. In the cutting parameters, you can specify the tolerances in here for your roughing process. Leave some stock after it's being roughed. You can control the step overs in here for pocket or cavity regions, and also for core regions. The system can automatically analyze the part and determine what's a core and a cavity. So in this particular case, most of it would be like a core region because it's like a raised extrusion, right? So if there's a cavity, then it would use a pocket cut pattern, whereas it'll do a facing cut pattern in here. and you can specify the cut levels, how fine you want to cut at a step. The default is 50%, and how far down you want it to cut. So you can choose how deep you want it to cut in here. And in the agent retracts, you can control the ramp motion, and then you can also do the arc fitting and advanced cut parameters in here, where we can fit true arcs to toolpaths, and I would typically use 2 times the tolerance I have for the global parameters, and then pick generate. In this process, it's going to analyze your part, analyze the stock, and create the roughing toolpath.
Okay. You just selected the surface for that.
I didn't pick any surface or any geometry. It automatically computes the base of the part in the stock. So.
Oh, I see. Dylan, did you say you had to explode the part before you did this?
I'm sorry, can you repeat that again, please?
Did you say you had to explode the part before you did this?
I do not have to explode the part. The reason I exploded the part was to get the orientation for using the orient part command. So it is not required to explode the part. So now you're noticing here that it's cutting based on the stock, the entire stock that you have right there. So the roughing automatically computes it based on what you have defined for the stock. I'm going to speed up the simulation in here a little bit.
Yeah.
Kind of see that it's basically starting from the outside and working its way in towards the part.
I see.
Now, if the tool is not long enough, the tool holder might collide with the part. You can actually view all of those in your simulation here. So if you do a simulate to end, it'll run through the simulation, and if there's a collision, it's going to mark those areas in the simulation.
Okay, I see.
The red areas are the collision.
And that's where it's really helpful to make sure that you're accurate with your collet diameters and...
That is correct.
Yeah. Okay.
And it'll also flag the operation as dirty once it's done with the simulation, and it'll mark those, the toolpath motions in the toolpath viewer. You can actually double click on it and launch the toolpath viewer, and it'll show the lines where there's collisions. If you scroll through here, once you get past a certain area, you'll see all of those collision areas in there.
Yeah. Okay.
So we should get these guys to use that.
And all of those areas you're going to have collision. As you can see, it's colliding with the part.
Right.
So either you need to use a longer reach tool, or you need to reduce the depth of cut as you're cutting it from one of these directions in here. Now on this side you're okay, but on this side you seem to have an issue, right? While cutting it. So one of the things you could do is define a boundary in here and tell it how much of area you want to cut, rather than having to machine all the areas in here. So your boundary could be as simple as defining a rectangle, or it could be even a complex geometry in here, any complex curve. So in this particular case, I could say I just want to throw in a rectangle in here, and I can specify to just go right up to maybe a midpoint in here, right there.
Sure.
Right, or I could even start over here, and I can go right up to a certain area right here.
That's fine for the really big thing that's not happening.
And I can basically create this boundary in here. So the boundary is basically you want an area to contain the toolpaths to.
What is the maximum?
Okay.
The other thing you could also do is you can put a surface, so you don't cut past a certain side from the bottom, because over here you got to machine this anyway from the bottom, right?
Right.
So what I could do here is select that surface, and I can draw a plane, or I can put a rectangle in there. So one of the ways you could do it is you can extend that out further. So you don't want to cut past that. You can even draw a simple plane in there. So I could go into a rectangle command, and I can say I want to use this,
So that's what we would follow.
and I'm going to go to the top view here, right? I'm going to put a plane in here. So right up there, I'll just draw this, and I can select that and then say I want to create a surface from this. I can say surface using a planar curve.
Yep.
Basically an hour.
Now you could do the same thing over here too. Maybe you can have one over here depending on, what areas you don't want it to cut. You can put in areas that you...
So do you make that plane, you just make that as a boundary, or how does that work into
So
RhinoCam?
if you take a look at this, if you look below the plane, you can't cut anything into it because that's like an undercut. So
Right.
RhinoCam
I see.
will not be able to machine that's anything that's below the plane, and since the stock is over here, it's not going to go past that area. Now, I could do a similar one over here too. I can use the same information and maybe have a plane right up
Yeah, I
to
mean, I can make a surface just extended from that whole underside and just extend that whole surface so that it doesn't cut, it never cuts out.
Absolutely.
Cool.
And I can have all of these in a new layer, and I can hide them when I don't need to have them visible.
Right, exactly.
Now, if I go back and repeat the same roughing operation again, if I go back and regenerate it, so you see it automatically flag the operation as dirty.
Is that what that little star is or whatever?
Yes. Since you made a change to the design of the part itself, it flagged the operation as dirty. So now when you regenerate it, it's not going to go cut past this. Now if you want to lower this a little bit further, you can do it and then regenerate the toolpath again. So it is recomputing your roughing operation. I can also regenerate the drill operation at the same time while it's being computed.
Let's see. Now for tool changes, it automatically configures tool changes.
Yes, it does.
And then a person door. Person door. I don't know. At least
So it is generated. Now let's go ahead and run a verification in here. I'm going to do a pause and simulate to end, so you can actually see that
Oh, cool.
there's only two areas where you're still having a collision. So I can go back and change the tool length in here to account for these, right? So the tool is a little too short. Maybe you can have a tool that's 120 or 25 millimeter in length. So I can go back and change that, regenerate it, and then once it's regenerated, you can go back and simulate it again.
Okay.
So once you're through with the, sorry, go ahead, sir.
I was just wondering, so there's also like a tool library that is generated. Is that just generated through, like when I go through and I add, edit, create tools, will that stay in there for like my next model, for instance, or is this something that should be making in a separate document?
Yeah, so RhinoCam has a default library for English tools and millimetric tools. You can load those tool libraries and customize them to what you have, and then you save them to your own library. So you can have one or more or as many libraries as tools. And if you have, like, for example, based on the materials you're cutting or based on the different machine tools you can have different libraries. And once you load a library, the same library will be loaded automatically the next time you program a part. So you don't have to go back and try to find the library and reload it.
Mm-hmm.
So here you can see that it's still doing a collision, but it's much less than what you noticed in the past, right?
Right.
Okay, so now once you're through with the roughing process, you want to go back and do a finishing cut. So in this particular step, we want to do a finishing in levels because there's steeper areas on the part. So I'm going to use a method called horizontal finishing or finishing in levels. And for that, I'm just going to basically create a little boundary in here. So I want to keep the cutter inside that area only and not go past it. So I'm going to just throw in a boundary in here. And I can specify, it's just a large boundary, so I want to cut only around here because I don't want it to go past this. I don't want it to, cut the vertical edge on the side over here. So I'll do a 3-axis horizontal finishing. This is also in your standard configuration. You can select that boundary. You can pick a tool, half an inch ball mill or 3/4, quarter inch, or whatever you want to use, right? You specify a tool for it. You can save the edits on the tool. You set your feeds and speeds and clearance. In the cutting parameters, you can specify the tolerances. You could do climb, conventional, or you can alternate between climb and conventional. And you specify generate, so compute the toolpath. So this is going to do what is called a finishing in levels, or also known as Z-level finishing. Now if I go back in here and change the length for the first operation I use, I'll make this 150, and hopefully that'll work okay on this operation in here, the first one.
So now the length of the tool, though, like it's good for me to know, and it's good for the machine to know, so I can, for instance, when it has a collision. But in terms of the actual real dimensions, that's really determined by the operator on the machine.
Right, the distance from the tip to the spindle face, or the collet face that we would call it.
Yeah, exactly. It's really determined by.
Yeah. So now you can see it's doing a finishing in levels. This is called horizontal finishing, or also known as Z-level finishing. And it's basically cutting down in levels or steps, as you notice it.
So now if you hadn't have put the boundary on, it would be also cutting the side?
Yes, if I had not put the boundary on, it would also gone past these sides in here.
Okay. And how did where did the boundary apply? What did you do to, I know you drew the rectangle, but where did you?
So I go to the operation in here, and you have control geometry. You can click on select curve edge region, and you select it, or if it's already pre-selected. And now you'll also notice that it was able to, if it is cutting into any of the holes in here, you can exclude it, but looks like it did not get into any of the holes because the cutter was too big for those.
Right.
So that's a finishing in levels. You see the nice finishing toolpath. And now you want to do a post process, right click and post. I can say I want to put it on my desktop here. I chose the inch post, but if you want to put in millimeters, you can do millimeters. And then you select post. It's going to generate the output file, and there's the posted code. You can see your tool numbers being called out.
Okay.
So you have to drill, it goes to tool number 1 for the roughing process, and then you can look for the next tool.
Okay. So also since I did this in millimeters, my machine, everything is in inches.
So I can change it to the inch post processor. So when I do a post, I can select inches, and it'll do the scaling of the units from millimeters to inches at the time of post processing. So you'll notice that it's all in inches.
I think it's fine for something that...
And the feed rate is output in millimeters or per second or inches per second. That's what the machine tool expects. So we do the scaling of that as well.
Okay. Yeah, I was just going to say that was different.
So now we need to machine this side number 2, right? You would actually have to flip the part over and machine it.
Mm-hmm.
So if you were doing this in the standard configuration, then you need to actually flip the part in Rhino, flip it over 180 and save it as another file. So here I can save this as side number 1.
Mm-hmm.
And then it would have to flip the part and program the side number 2, so which means you reorient it so that you establish your XYZ coordinates.
Right, exactly.
So in one of our higher configurations, we have the option, rather than having to flip the part, we can actually flip the coordinate system in here. So I can specify the rotation angle of 180 degrees. So basically the coordinate system is being flipped.
Oh, okay, cool. Nice.
So that flips the coordinate system. And now I can go ahead and set a work 0. And I can put it to the lowest Z, if that's where you want it.
Does standard have work 0 or no?
The standard has work 0, but not multiple setups or creating additional setups for each orientation.
I see.
So this was one of the features in the Pro, where you can do multiple orientations. So I can then pick the 0 location, or if you want to, so you notice that now the 0 is set over there, or I can even pick a point where it makes it easier for us to specify the location. So we may not have this location in here on the table, right, because that material was already cleared out. So also the nice thing is you can run and see the simulation from multiple orientations as well.
I see. So basically it knows what stock is left.
Right. And the Pro also has a method called re-roughing. So if you want to rough it out again, and also wanted to take into account what is the stock being left, you have the re-roughing operation. With the standard, you can do a roughing operation by defining like a containment boundary in here. So I can switch the view to bottom, and now I can create like a boundary in here to contain the toolpaths. So if you notice this here, I can draw like a boundary. So I can use the tools that are available in Rhino. I can use a command called duplicate edge to create a boundary. Or if I just wanted to keep the cutter in this area, I could do a roughing operation again. So I'm going to make a copy of this roughing operation and paste it in here. And I'm going to pick a boundary, and now I can even select a edge around the part, a face edge.
Oh, cool.
So I'm just picking a bunch of face edges. So as long as it's a closed loop, you would be fine
Right.
for the boundary.
So it'll take the original horizontal roughing and use the same tool, same spindle speed, same everything, except now it has a different surface.
Now it actually has, what we're trying to do is a different orientation we're trying to cut it from, right?
In the different orientation, right.
Yeah, so you're trying to cut it from a different orientation. And I'm just going to go with the same tool, and then I'll pick generate. So you will now notice that it's going to create a roughing toolpath, and it's going to contain it only to this area.
Let's see. And we're looking at the old roughing toolpath.
You're still looking at the old roughing toolpath. That is correct.
Yeah.
So it's computing it right here.
This should not have any collision.
And once that is computed, so you can see that this is the boundary we are creating, and there's the toolpath roughing.
Okay, cool. And the red is just showing where it comes above.
Transfer, that is correct.
Right, right when it comes clear above.
Mm-hmm. So basically, I'm using that as the area to contain the toolpath. I'm going to do a pause and simulate to end. And let's run through it.
Right. What is the automatic distance that it clears over the tool?
That the automatic clearance is a 1/4 inch, or if you're working in millimeters, it's 6 millimeters.
Okay.
So now here you can see that there was a collision with the stock plank in here. Now, this could have also been cleared out. We could have drawn a larger boundary to clear it out, right?
Yeah, I see.
And you could have actually put like a little shoulder in here, so the cutter doesn't, get in those areas.
You don't have to cut it all the way down. You can just put a shoulder and just clears it perfectly.
Yep, there's your roughing, and then I can go ahead and process a finishing operation. We can do like a parallel finishing.
Mm-hmm. So the parallel finishing versus horizontal finishing, my 3D cam skills are not as good as my 2D.
Well, parallel is for areas that are in like vertical or steep, near steep areas. So it's more for sculpted surfaces. Parallel finishing is ideal to program it.
What's the main difference with it? What does it do?
So parallel finishing creates toolpaths in like parallel planes.
I see.
Horizontal is for, it does like a profiling, following the contour and stepping down in Z levels.
I see. Okay, that makes
So this would be a parallel finishing it's running.
Perfect. Okay, I understand now.
You might have to roll them in there and stir them in. Yeah.
So there's the parallel finishing.
How nice we want to do our tools.
So
But one way to do that.
Cool.
it's nice to be able to see the simulation from multiple orientations, as you can tell right here. So you can see that the hole was drilled all the way through or not based on what you put in from the parameters on the other side. So this helps you really visualize what you're cutting.
Right.
And each setup can be output as a separate file, like an NC file.
Would it ever show, like, for instance, I was doing a rough cut and I accidentally made it so that it was cutting into my material?
Yeah, if you overcut it, if you overcut it, then you will actually, you can do a comparison of the part and the stock that's available in expert and higher configurations of the product. So you can actually compare the part that you model to the cut material simulation.
Okay, cool. But that's not in standard?
That is not in standard. That is correct.
Sorry, I don't know if you can hear that with helicopters landing by, or 2 helicopters landing by us right now.
Okay.
Cool.
So this is
you pretty much answered all the questions I had to you while you were doing this.
okay. So this is one of the ways how you can do a finishing. There's also a spiral machining toolpath available to you in standard as well. So you can use the same boundary selection that you had for parallel finishing.
Does it ever give you a length of time for it to...
Yes, it would, and I'll bring that up here in just a moment. So I'm going to pick this boundary in here. We could do a parallel finishing if you want to take a look at that. So Rhino also has a chain command where you can select a chain of edges in here. So you basically pick these chain of edges and then use them as your boundary for the toolpath. So this would be it says open loops found, so it tells me that the yeah. So what I could actually do here is I can create an outline from these two. I can select these two surfaces and I can do a command called mesh outline in Rhino. It puts a nice little outline for us in here. I can set it from the bottom view here. So I can do a bottom view. You can just pick these two and do a mesh outline. Okay, so that gave you a nice little outline around the part right here. And I can use that for the spiral machining. So I can pick that curve and generate a spiral machining toolpath. So it does a nice spiral toolpath.
Okay, very nice.
So you could use different types of techniques for programming it. Now with the Pro you have more options. You have methods like projection pocketing, constant 3D offset pocketing. So there's more options for you in the Pro for finishing.
Absolutely, I see.
And then you can post-process each operation out, each setup out separately because you're going to be flipping the part over manually on the machine. You can also look at the time. If you right-click and go to information, it's going to tell you how long it's going to take to cut based on the parameters we put in for the feeds and speeds. And you can optimize some of the parameters, go back and make changes to it.
So
See that the roughing is going to be the longest time in here when you're cutting it from the other side. Maybe you could do a an operation to go ahead and clear out some of the excessive material and then just have it rough in some of these areas in here. So if you take a look at it from the top, you could actually go ahead and just put an area just around here to rough it out.
Right, I see.
And not have it do the entire, areas in here, so you can basically contain it, and all of this can be cleared out in like a different process in here with a much larger cutter.
Right. So you can get down a lot more because it's flat.
And then you can save all of these operations. When you save this file in Rhino, it automatically saves all of the machining operations with the part. And you can also take all of these operations and save them out to a knowledge base. So when you have parts that are similar to these, that require a similar type of programming workflow, you can load them in on other files. So you don't have to go through the process of redefining each and every parameter. You just have to load the knowledge base and then pick regions if they're required, or you don't even have to pick a region if that's not needed.
Sweet. So it could take, like, for instance, the same tool with the same steps, with the same...
Same step over, same cutting conditions, but on a different part, different family of parts.
Yeah. Maybe same material too, even. Where does the tool... I was trying to find the tool library that came with RhinoCam.
So if you select Load Tool Library, it'll point you to this folder called RhinoCam and Data. It's under C drive, program data, and then by default, There's a library called
Over here.
English tool and metric tool. They're in .csv format.
Right, I couldn't find that last time
And
I
you
was
can
in
select
there.
the library. If you're working in millimeters, you pick that and then pick open, and that'll load it for you.
Storage for tools.
All right. Let's see if I can grab it. Because last time I did that, I was trying to
Bag.
find the library. I
Consumables.
could not find it. See, okay, load tool library. I'm just doing it on my computer right now. So I go to data. It said RhinoCam, which is in my C drive and data. Nothing shows up.
Okay, I can certainly take a look at it on your screen
I
and
see
help
it.
you out.
Wait, actually, never mind. We totally have it right here. It was looking for the wrong things. Okay, cool. I just loaded all the tools. Awesome. I just didn't have it as a looking for the wrong file type.
And then you can modify the library and make changes as needed.
Okay, awesome. It doesn't automatically set these to a tool number.
Yeah, the tool numbers aren't defined in the library. You would have to set them because it could be different for each tool.
Right.
For each
Usually
user,
defined.
yeah. So,
Okay.
yeah, this part looks like it's more of like a prismatic part, right? Where there are
Exactly.
many drafts, you can do like 2.5D operations. So the workflow will be the same. So you can rotate the part if you want to flip it over. Use the Rhino's rotation tools in here to rotate it. You can use the controls that you have in Rhino if you want to do that for orienting the part. So now it's oriented. If the router that you have has more travel on the Y as compared to X, you can always rotate it again. You can do a 90-degree rotation, right? Or you need to adjust it, you can do that as well. Or if you want to undo it, you can leave it the way it is. And then the workflow is very similar. You specify the stock material for it, and you can specify the length. It says 2699, width is 908, so I can say it's going to be maybe 2750, 1000, or 950, and then 50 millimeters height, right?
Sure.
And then you align it. So the workflow is very similar as you noticed it here. And then you pick the location of the origin. You can do stock box, low as Z, southwest.
What happened to the stock box?
It's show or hide. There's a toggle in here to hide or show it.
I see. So all the bottom controls there are kind of display settings.
Yes, these are all the display controls. That is correct. So I see that the exterior of the part has a draft on it, right?
Correct.
Okay, so I can load the entire knowledge base in here and use it by going to load knowledge base, or if I specifically need a certain knowledge base in here, I can just load that particular one in here. So you can see that the knowledge base I created was in RhinoCam 2018 for Rhino 5 data folder. I'll just grab that in here and you can see all the operations are loaded now. So
Okay, cool.
I may only need, the horizontal finishing. I may not need the setup number 2, or if you need the setup 2, you can have both the setups in here. For the drilling, I'm just going to double click on it here and say select holes on the face. I'm going to pick that place right there, and you can see it picked all the holes. I can pick where I wanted to start the cuts from. I can say pick top if I want to start it at the top of the stock material or the part material. That would be 0, or in this case it has to be 50 millimeters, right? The top is 50. And I can specify how deep I want to go is 50 millimeters or 50 point, right? 50.1, or if you want to go slightly deeper, the add tooltip to drill depth will take care of that, and I can say sort the holes in a pattern. So the knowledge base did the trick. You need to make sure that the hole diameter is correct. Analyze diameter. It's 11, so that tool should work okay for now, right?
Absolutely.
So there's your drilling operation. And now you want to, program this draft in here that you have. So you could program the draft using the horizontal finishing, and I can pick this as the boundary in here for the draft. I forgot to pick one of the edges in here, and I can set the cut levels to only go down to this area right here. or you want it to go down here, you should be okay. So it'll cut this draft and also over here. But before you cut this step, you want to restrict it down to this level. And I can go ahead and generate the toolpath for that. And then also I want to do a pocket operation in here, 2-axis pocket machining or a profile cutting, just to relieve this material on the inside, right? So if you don't want it to hog everything out in here, you can do a profile cut, 2-axis profiling.
Okay, awesome.
And I can do a select chain in Rhino. I can use a chain segment command, select that, and prick the same end mill that we had, and choose what side you want to cut. The cut levels can be set directly off the part. Or you can say however deep you want it to cut. You can ramp it along the path and generate it. So after the drill, we could do the profile cut. And then we have the horizontal finishing. That's basically the Z-level finishing. So it's following the draft on the part and does a finishing cut.
Very cool.
So before you do this step in here, you could also clear this material out using a profile operation. I can repeat the same profile operation in here and use this select chain command. Pick this chain, so it automatically picks the chain right there. And the cut levels, I could say it's at the bottom. I can do like a 5 or 10 millimeter cutting width in here. So that'll do multiple passes, or I can add a few more extra passes in here.
When you say at the bottom, it picks the bottom of the surface. It doesn't pick at the bottom of the stock.
Well, it's the bottom of the surface, the geometry what you selected, right? That's the floor.
Great.
Okay, so now you're basically relieving this material out first. And then you're doing the next profile in here.
Yeah.
If you wanted that to go deeper, you can change the depth to, let's say, 20 millimeters or 15 millimeters, whatever that needs to be.
Mm-hmm.
So you have all of the control that you need in here for programming it. And now you also want to do the finishing that basically machines that draft around the part that you have. With a ball mill, or you could even be using a flatten mill, whatever tool that you want to use for it. So I'm going to just do a pause in here and then pick simulate to end. So it's going to run through the simulation. Do you have any questions so far?
No, this is perfect. Slight, actually, maybe not. I'm trying to remember if there's a slight draft in that exterior part.
Yes,
I think
so
there's
the interior has a draft. I did notice an exterior draft as well, so we could do a similar process for the exterior too.
yeah, it's really minimal.
Right. You can see the power of knowledge base here, so I didn't have to go through a whole bunch of programming. And the two parts are totally different. They're not even identical or have anything in common, right?
Right.
So we were able to apply the same toolpaths, like the drilling and the finishing operations to this.
Yeah, no, that was super awesome. But you have to save the knowledge base from the last.
Yeah, knowledge. You can even open the file and save it at a later point of time too.
The materials that are loaded, do you find those to be really useful? Or do you usually just use your own material feeds and speed rates?
So the load from file option that you see is more like a reference for you to come up with your best practices. So you can use that as a starting point, a good reference source, and you can even customize it to have your own material types added to the list.
Okay, you can even customize it.
Yes, so if you go to this materials, there's actually an XML file in the folder where all the data is saved in here. So I'll bring this up here. So there's a feet and speeds inch and a feet and speeds millimeter. So if you right click and open this with like a text editor like a notepad, you can actually add additional material types. You just have to maintain the same formatting indentation. You can add new material types in here that you typically work with, and you can add the name of the process in milling or drilling and turning we have, and then tools. It could be carbide, high-speed steel ceramic, or if you have a new tool, you need to add a new one in the list here for each.
Okay, cool.
So that's how you can go ahead and customize it. So you can use a similar process for the outside in here. So the outside, since you only want to cut around the outside and not go in again, one of the ways you could program this would be to basically extract the edge from the outside and then offset it so you can pick two areas to cut it. So we could do, I'm going to do what is called a duplicate face border in Rhino. I'm going to pick that face. It actually creates a boundary in here which follows around the entire part. I'm going to take this and offset it towards the outside by the cutter radius at least. So I can say maybe 10 millimeters, for example, right?
Sure.
So now I can go into the horizontal finishing. I can make a copy of this again. Control C for copy, Control V to paste it. And I'm going to pick, this is the area to cut, but then I don't want it to cut inside this edge, or I can just pick the inner, the inner offset edge that I have in here. So when I select these two, the tool is only going to stay between these two areas, and it's only going to cut the steep sections between the two areas.
I see. Can you go to the perspective view for a second?
Yeah, or I can even drop this one out, and I can just pick the edge that's over here. And I can pick this one. So everything that's between the two will get programmed
I see.
with the finishing in levels, or horizontal finishing toolpath. So it's not going to cut any of these again, recut any of those areas again. So that's how you can get precise control by defining your boundaries or cutting areas.
Could you theoretically have just selected the part into the horizontal finishing and it would have
Yeah, we do have an option to select part surfaces. In this case, a boundary was the much more faster way to select it, because then you didn't have to go through the process of picking each of these surface areas.
Okay. I see. Horizontal finishing really takes a bit of time.
Yes, it depends on it looks into account the everything is based on the solid geometry or the surface or mesh geometry. We can even work with STL files. So the complexity of the model, the computation time could vary anywhere from a few seconds to a few minutes. Now, the reason it's taking longer here is I probably have the part sampling resolution set all the way to fine. If I slacken that, if I set it to standard, then that might run faster.
I see.
So it's over here. There's what's called a part sampling resolution.
I
had it
saw
set to
that.
fine. So I'm going to change this back to standard. And now if I go back and regenerate it, you will notice that it's going to be much faster, the computation. And it looks like this surface is not perfectly flat. There could be some variations in here. So I can pick this surface and also use that as the boundary, between these two as the boundary. So now you notice it was much faster in here, right?
Right, exactly. Also
And
the surface is a little choppier.
also I need to go ahead and offset this out further. Maybe I'll do a 25 millimeter offset. That should work. So I can go back and edit the operation. Just repick these two areas here. Okay. You see that the toolpath computation is now much faster, as you noticed it.
Absolutely.
Okay. And since I had some containment put in here, it's just not going all the way down to the bottom. So if I remove these containments, you'll see that it'll go down to the bottom. So even the container information was being
Was being taken
loaded
from the next
knowledge base, yes.
Right.
So that was the reason why it wasn't cutting all the way through, due to the containment.